So there is quite a lot of debate as to which research designs are best for certain kinds of research questions. When it comes to single subject research and group-based research, there's a lot of benefits and costs to both kinds. But they do have a lot of stuff in common, in fact. Single subject research and group design are similar in many ways. They're both quantitative approaches, so they both involve collecting a large amount of data. They both try to establish causal relationships if you're doing experimental research. And they both involve manipulating one variable and measuring another, cause-effect relationships. Also, they both attempt to control extraneous variables. But, despite all these similarities, there are some important differences that I should mention as well. And these differences are where the disagreements come from. There's three fundamental differences between single subject and group designs. First one is that single subject design obviously only includes a single subject. That one's kind of an obvious statement, but it is an important difference. The second one is that single subject research tends to be much more flexible, and that it can be modified or completely changed in the middle of the study without affecting the integrity of the study. In the previous video, I was talking about how you don't have any preset time when you switch from one phase to the next. And if one of your treatments isn't working, you don't have to throw away the whole study. You can just switch to a new treatment. You're very flexible like that. But you just can't do that kind of stuff with the group design. And then the third one is that single subject designs obviously require continuous assessment. So you're going to have to be following that single person over perhaps a long period of time. Now, there are some big advantages to using a single subject design. You could basically say there's three main advantages. First one is single subject design allows researchers to establish a cause-effect relationship with only a single subject. And that can be an incredibly powerful tool to have. Like if you only have a single subject that could possibly participate in your study, like maybe you're interested in some rare phenomenon, then this would be a great way to test that person, that very rare individual. Another big advantage is that flexibility I just mentioned. If you're pressed for time and you're pressed for resources and you need to try to get those treatment effects fast, like maybe your client, maybe your participant is suffering from some disease and you're trying to find a treatment, I don't know, something like that. But yeah, if you're in those kinds of conditions, you can just keep trying things until you find something that works. You don't have to completely start over every time you have a failure. And then the third one is that there's no need to standardize your treatment across groups. When it comes to group research, standardization is a very important thing. You want to make sure every participant gets the exact same treatment. You don't want those individual differences to cause problems in your study. But when it comes to single subject design, you can just forget about all that. None of that matters. All that matters is your client, is your participant responding to the treatment or not? So for these reasons, single subject design are great for clinical purposes, like those examples I mentioned. In fact, if you are a clinician, if you are working with people who have various kinds of medical or psychotherapy kind of needs, then you're most likely going to be doing a single subject design. It's not always obvious which treatment will best help your client. So that's what a lot of them do. They'll try a treatment, they'll observe your progress, and if you're not making much progress after a while, then they'll try something else, and then they'll try something else. And they keep observing and looking for those kinds of changes in your behavior to see if this new treatment is having an effect. But obviously there's some disadvantages to using a single subject design. there's three major disadvantages. The first one is, if you do observe a relationship, if you do observe like a treatment effect, you're only observing that for a single person. And that can be a big problem. Remember, the whole idea of psychological research is we want to learn about humans. So if you're trying to learn about humans by looking at just one person, that's kind of a hard leap to make. So you're definitely going to have a big threat to your external validity here. Another one is that multiple continuous observations are required. So if you think back to the kinds of studies, research design we've talked about before, whenever you're measuring people over time, there's a whole number of things that can happen. You have those time-related threats to your study. Things like participant getting bored, things like the participant getting more skilled at the task that you have them participate in. Or maybe the participant just disappears, maybe they moved, or maybe they got sent to jail or something. Like, anything could happen during the course of your experiment that could ruin the whole thing. And then the third reason is, we don't really have any kind of standard way to analyze data. We have that visual inspection I've mentioned previously, but that's kind of not taken all that seriously from a mathematical perspective. If you don't remember what I was saying about visual inspection, what I literally said is, when it comes to single subject design, we just look at the data. You just look at it on a graph, or you just look at the numbers, and based on how those numbers changed, you make a decision. So we don't really have any statistics for single subject design. But when it comes to specific single subject designs, like the ABAB design, there are some pretty big limitations. The ABAB design, it can establish a cause-effect relationship by going from baseline to treatment, so you're turning on the effect, and then back to baseline to show you can turn off the effect, and then turn it back on again by going to treatment again. But withdrawing treatment in the middle of a study could be problematic. Like, for some treatments, withdrawing it, trying to go back to baseline, trying to turn it off, like I was describing, that's just not going to have any effect, because your treatment is like a long-lasting, or maybe it's even a permanent effect. So if you have any reason to think that your treatment effects might be permanent or long-lasting, then an ABAB design simply will not work. Another reason why you might have a big problem using the ABAB design is if you might do harm by withdrawing that treatment. This is something I mentioned previously. For clinicians, for psychotherapeutic research and stuff like that, you don't want to take away a treatment that is seemingly working. If your client, if your patient is responding to a treatment and they are showing signs of improvement, obviously it would be horrible to take that away from them. So you simply cannot do an AB design with those kinds of situations. Now, with regard to the alternating treatments design, that has its own advantages and disadvantages. The primary advantage of this design is that it allows you to rapidly compare two different treatments. Like I explained in a previous video, with the alternating treatments design, you're not waiting for a stable state or a stable level or anything like that. You're just rapidly switching between the baseline and the treatment, and the baseline and the treatment, back and forth and back and forth. And as you can imagine, by having a single observation of baseline followed by a single observation of treatment, you could establish a cause-effect relationship. You could establish the existence of treatment effects in just two observations. So you can rapidly identify those kinds of effects using the alternating treatments. So yeah, this can be very helpful when you want to quickly determine what the most effective course of action is for a particular client or certain situation. But the primary disadvantage is that if your treatment effects aren't immediate, if by switching to the treatment phase, if you don't observe a change instantly, if there's some kind of delay perhaps, then that's going to completely ruin your entire design. So carryover effects, treatment latency effects, these kinds of things are major concerns when doing an alternating treatments design. So this is why it's a requirement for this design that the participant show an immediate response to the treatment effects. Now, regarding the multiple baseline design, that also has its own strengths and weaknesses. The primary strength is that it eliminates your need for a reversal. So like I was describing earlier with the ABAB design, you have to be able to turn on the effect and turn it off again. But with multiple baseline, we don't have to worry about that. We can just turn it on and leave it on. And when it comes to clients that are potentially receiving a life-saving treatment or something like that, then this is wonderful. This is exactly what we want to do. We want to help them, and that's it. We don't want to have to take away this thing that's helping them. So multiple baseline is ideal for studying things that you either can't take away or don't want to take away. But there is a big weakness here, and that is that the clarity of the results might be confounded by individual difference, like variables. You know, it might seem strange to think that individual difference confounds are part of single subject research, but they are when it comes to multiple baseline design. Because if you ever need to compare more than one individual, these confounds are going to come in. For example, one participant might just show larger treatment effects than the other. But there's another weakness. Another weakness of the multiple baseline design is that when you look not across individuals but across behaviors of a single person, or when you look at, the same behavior across different situations, those different behaviors or those different situations, they might either be too similar or too different. So it's kind of hard to find equivalent but different situations and behaviors. So it can be pretty tricky to do those different variations of the multiple baseline design. Now, another big concern that people have regarding single subject research is that visual inspection. When it comes to data analysis, a lot of people are heavily critical of single subject design. Group researchers often worry that this visual inspection is simply inadequate for deciding whether and to what extent a treatment has affected a dependent variable. When it comes to doing visual inspection, you can't easily take what's being presented in one study and compare it to another study. That's the big benefit to doing statistical analysis, is that we have standards. We have standard statistics that we can share, and we can, look for connections and similarities across multiple researchers' work. But that just doesn't really happen when it comes to visual inspection. There's no real easy way to do that. Another big concern is that this visual inspection may simply not be sensitive enough. When you look at the data and you fail to see a difference between baseline and treatment, maybe there isn't a difference, but then again, maybe there is, and you just can't see it because it's so small. Another one is that it can be unreliable. This one seems to be the most obvious. If making a decision as to whether or not a treatment works, if that's left entirely up to the researcher, human error is always going to play a role. Some people are just not going to notice certain things. Some people are just going to make bad decisions. So human error is always going to be a problem if it's left up to the humans to make those decisions. But single subject researchers argue that when we use things like the steady state strategy, that can help to minimize these kinds of concerns. And that is a valid argument to make, but for a lot of group researchers, that's just not good enough. But conversely, single subject researchers also have problems with group research design. They often point out things like focusing on the group can be highly misleading. I don't know if you've ever heard these kinds of things like the average family has 2.5 children or something like that. Like, there's no such thing as an average family. There's no such thing as 2.5 children. These are abstractions. That's kind of a big problem when it comes to statistics, is when we start computing averages and standard deviations and things like that. We're not talking about humans anymore. We're talking about these abstract concepts that don't exist in the real world. And that's exactly what single subject researchers are trying to get at. They're trying to look at real people and a real situation. And they just argue that group researchers, they can't do that. Like, imagine, for example, that a treatment has a strong positive effect on half of the people in the study and an equally strong negative effect on the other half. If you're doing group research, you would just compute an average and you would find that the treatment has no effect whatsoever. But if you were to look at individuals in this example, you would see that some individuals are going in one direction, some individuals are going in the other. So that's just another example of what I mean when I say computing averages, computing these descriptive statistics can be misleading. It can lead you to the wrong conclusions in some cases. Now, a very valid criticism of single subject design that group researchers will often point out is what the whole goal of doing research is to generalize to the entire population. We want to know about all humans, not just one person. But single subject researchers can address this concern by doing the following. They can look for strong and consistent effects, which are more likely to generalize to other people. And they can try to replicate the results across numerous studies with numerous different individuals. And they can also point out that a lot of single subject designs have been successfully generalized in the past. Like, think about operant conditioning. People like B.F. Skinner, they looked at single rats and observed the behavior of single rats, and were able to then generalize that single individual's behavior to other rats and even other animals and even humans. So we have done this kind of generalization from a single subject before. It's just perhaps not as common as you might think. Now, single subject researchers also point at the same problem with external validity. So they often argue not that we can't generalize from one person to a large group, but you can't generalize from a large group to one person. So it's kind of like the same argument, but in reverse. Because if you think about it, the whole idea is to generalize from our study to the larger population, but we don't really want to know about the population. Knowing about humans is not actually the goal if you really think about it. What we want to learn about are ourselves. We want to learn about, Steve. We want to learn about Vanessa. We want to learn about Jessica. We want to learn about individual people. We want to know how this study's results can be applied to an individual person. So that's exactly what these single subject researchers are saying. If all you do is group research, we lose sight of the individual. In other words, you can learn about the average human, but you won't learn about Steve. Another concern of group research is that it's often conducted in a single situation, which can make it hard to generalize to other kinds of situations. Like, if your group research was done in just one place, like a college classroom, then we might not be able to observe those effects outside the classroom. But when it comes down to it, group research, single subject research, they're not really, debating. They're not really at odds with each other. They're actually complementary methods. That's how we should see them. Because single subject research is good at learning about the individual. It's good at learning about how Steve is being affected by the treatments. Whereas group research is very good at learning just in general how effective does this treatment tend to be. So if we look at the group data, we can get a rough estimate how it might affect a person. But if we want details as to what those effects might be, then we would look at the single subject research. So they go hand in hand. They work together very well. And together they can be used to understand the experiences of the individual and make predictions about anyone.